Hello everyone, good morning. My name is Rob Court and I'm here on the Digital Hub today. And the Digital Hub, as you all know, is a place where students and staff can get support on how to use the digital tools that we all have in common. But today we've got a really great opportunity because we're actually got some speakers from outside of the university talking to us about other digital tools. And this particular speaker is Holovis, and we've got Professor James Brownjohn here as well. And they have been working on some VR equipment with the university, and they've acted as supplier and the academics involved. And they're going to be talking today a little bit about how digital tools can be used in their application and in the real world. And this is quite cool. And all through the week, over this whole week, we're going to have more and more events like this one. So we've got IBM come to speak to us, KPMG, we've got Red Cross talking to us about digital mindset. So we've got lots and lots of different opportunities. And even better than that, we're giving away donuts and drinks as well. So in the mornings, we've got iced coffees to give away. And in the afternoons, we've got gin and tonics and juice. So come along. We've got limited space on the Digital Hub, but you can come and see us and talk to us and listen to these great speakers. So I'm now going to hand over to Holovis. We've got Stuart Hetherington and Drew Dunk. And so I'm just going to put them live now. Okay, so I'm going to hand over to them.
Good morning, everyone. Back in 2000, the Millennium Bridge opened across the Thames in London. An incredible feat of engineering and with a very unique design and structure. However, as many of you may remember, not long after that opened, it had to close due to serious concerns over the structure and the movement of the bridge. The cause was something those engineers designing the bridge didn't predict. Perfect storm of engineering physics, triggering crowd dynamics, those walking across the bridge, and the patterns of those lateral forces exerted on the structure. That rhythmic nature of those pedestrians walking over the bridge created vibrations and resonance, specifically in the side support bars, that resulted in the swaying of the bridge. Essentially, the pedestrians' movements created a natural frequency that equaled the natural resonant frequency of the bridge structure. And when combined, we ended up with all that sway. Not ideal. So how did they fix that problem? They ran tests and simulations with lots of people walking over the bridge and recording the vibrations and those lateral forces. And then they damped the structure. They added shock absorbers to the support bars to absorb and dissipate those forces and prevent the buildup of the resonance that caused that sway. A costly, time-consuming exercise for all those involved and rather embarrassing. Good morning, everybody. I'm Stuart Hetherington. I'm the CEO here at Holovis. I'm joined today with our friendly tiger that makes sure we're all 2 meters apart. And we're a company that work with our clients to solve complex problems, utilising the experience and skills of a multidisciplined team to create immersive dynamic solutions that take researchers, engineers and designers and their real world environments and help them understand the experiences, the challenges they face, but done through virtual reality and simulation to allow safe recreation and repeatability of those structures and spaces. Your digital festival this week is about learning how companies like ours use digital tools in our processes, our development and our projects. And I want to emphasize that our approach to creating the type of immersive simulator systems we build, and especially the one we're going to show you today that we built in partnership with the professors at Exeter University, may look very much focused initially on mechanical and software engineering. However, the solution involved a much wider multidiscipline team, such as creative, media, real-time, game development, software development, mechanical and electrical engineering skills. And everyone had to come together and play nicely and work as one team and use all the different digital tools in each area of specialism to successfully create the solution you're going to see. Today, I'm joined by Professor James Brownjohn from the Vibration Engineering section of the College of Engineering and Mathematics and Physical Sciences at the University of Exeter, and our Head of Software Development and one of our engineering wizards here at Holovis, Dr. Drew Dunk. And together, they're going to show you the VSimulator project that we worked on and explain a little bit about the development of this very unique solution and the digital tools the team used to bring it to life. Hopefully you'll see that if the team working on the original Millennium Bridge had had access to this type of real world environment and structure simulator back in 2000, they may have been able to avoid those costly mistakes they found with their original design. by simulating and actually living and experiencing and feeling their design as though it was real and already built, long before they actually put those steelwork up. And I'm sure that it would have allowed them to identify those issues that they faced long before the actual bridge became famous for its wobble. So over to you, James.
Right, okay. Let's see if this works. So just try to share my screen. Okay.
Just putting you live now, James.
Okay, right. So I'm going to try to share my screen. Right, give me a minute. Find the right one. Okay. Here we go. Right, so this is what I'm talking about here. So this is the challenge which we're facing as engineers designing structures. It's working out what are the acceptable vibration limits for human-occupied and dynamically excited structures. So this is another example. So this is not the wobbly Millennium Bridge. This is a football stadium in Germany, not socially distanced, clearly. And this is an issue which is being dealt with by engineers like ourselves at Exeter. Our team helped to identify the problem with Millennium Bridge back in 2000. And we've also found that there are problems with football stadia and other types of structures. So UK stadia are designed to be safe, they're strong, they won't fall down, but they may not be stiff. And there's a very important distinction between stiffness and strength. And vibration engineering is a subject we deal with where flexible structures tend to vibrate too much, and dealing with it is a major challenge. And VSim is designed specifically to address this challenge. So it's not just wobbly bridges and stadia, actually, or even a concert venue. And here's another example of an impromptu concert venue. A little while ago, you may remember this one. This was not engineered and designed for people, okay? However, worldwide, there are thousands and thousands of structures which are not publicly visible, like Millennium Bridge, which go wrong. So there's a big problem of designing these structures, particularly floors, lively floors, which vibrate too much. If you don't do it right, if you under-engineer, then you're liable to get sued, lose business, and that's really, really bad news. The solution traditionally has been to over-engineer, to put too much material, steel or concrete, you stiffen the floor. But these days, that's really bad news because you generate lots of CO2 in over-design. In fact, maybe about 50% of the design of a building can in fact be due to vibration problems. And clearly that's not sustainable. So getting the balance right needs a mix of skills from maths to biomechanics, and primarily involves putting people in the live simulations. And until now, there's been nothing on the planet that brings together the technology we need to deal with this. Okay, so this is what we asked Holovis to create for us. So this is many years ago. We said we would like a motion platform, a big one, enough for several people to pretend they're in a football stadium, for example. We want to be able to capture the forces they generate as they move, they jump or they sway or they walk. We need to be able to capture the motion using motion capture technology, and we need to put people in virtual reality so they don't actually have to be in the stadium. They can pretend they're in the stadium with other people around them and experience it live. And there's a motion platform involved which brings people up to the limit of the uncomfortable acceleration, down to the sort of lower levels of an operating theatre where you're having your eye operated on, which is bad news if it's vibrating too much. Very delicate mechanical lower limit for the machine, and there's an upper limit for the stroke capacity. So we're operating in this environment, and we said to Holovis, please go and create this for us. And they went away and they did that. And this is what Drew did. Back to you guys.
Yeah, James came to us with these challenges, and we spent a good amount of time scratching our heads of exactly how we would go about implementing it. But we came up with a solution. It took quite a lot of skill sets from Holovis, from electrical engineering to mechanical engineering to software development, as we've said in the past, and also just media artwork, 3D modeling. And we spent About 1,500 man days, sort of designing, developing, installing the solution. And one of the important requirements is it's got to be something that allows Exeter to use this for multiple different scenarios. We came up with 3 main scenarios with Exeter to start off with, which was a stadium, a virtual stadium, a virtual office, and a virtual bridge. We produced this system to be able to allow 9 people in VR headsets. We're using the Vive Pros to stand on a motion platform that's able to meet these requirements from James of, as he says, from kind of imperceivable motions right through to uncomfortable motions on the platform. But the key part of the whole solution is obviously being able to capture the data. There's no point just being able to throw people into these environments just to experience it. It's all about being able to record the data that comes back from this too. So we have 9 force plates, anti-force plates, that are sat on top of the motion platform. We also have 4 very high precision accelerometers on the motion platform, because there's a difference between what you ask a motion platform to do and what it actually then moves. So we record the requests for the motion that we want to deliver to the motion platform, and then we also record the results of what the motion platform actually does. We have also then incorporated 16 OptiTrack cameras into the solution, and this allows us to do full body mocap of the people standing on the platform. And all of this data is synchronized together and packaged up into a session so that we can run sessions in the environment, load up these virtual environments, record and gather all of this data together, and sort of combine it, but all back together. So then James and his team and others can then dig through that data and try and understand exactly what's sort of, what's been going on in that scenario. So James, I don't know if you want to cover up a bit more about what applications you've done with the system so far.
All right, Drew. Okay, so let's see if I can pick up on that and reshare my screen and carry on from where we left off. Okay, so here we go. That's the right one. Okay, so what you see here now is well, it's not what you're seeing in Exeter now at the Science Park, which is where it lives, but this is partway through the delivery of the solution at the headquarters of the company E2M in Amsterdam. So E2M was subcontracted by Holovis to create the motion platform, which is an integral part of the VSim system. So the motion platform, well, it has motion, and this is a very sort of simple representation of what it does. So it's a 6-axis machine, which means it can sway in both horizontal directions, rather like the Millennium Bridge. It can also move vertically, which mimics the behavior of a football stadium, and it will also roll and pitch and yaw, which are actions which we do experience in civil structures. So there's quite a lot of roll and pitch happening on bridges, which we've experienced in the past. So while this is a very sort of atypical type of behavior, it's a very prescribed sinusoidal type of motion. We've got experience of measuring thousands of structures worldwide, and we have a large database of signals which we can replay. So for example, I can take my iPhone and sit on a train and I can record it and play it back through VSim. My colleague can take his boat on his boat and record the signal there. I can go on footbridges, I can go on stadia, and I can record. And as I say, we got measurements from buildings, footbridges, chimneys, all kinds of structures around which we can replay and make people think they're in these structures. And the idea is that if we can get this done better, if we can get people to understand what they're going to experience, we can help them design it better. So for example, if you're designing a super tall building for a sheikh in UAE, for example, you can put him on the VSim and say, is this okay for you, sir? And I'll say, no, it's too lively, and they will spend a lot of money making it better. So this becomes part of the design loop. So we can do everything we want to design civil structures, but so far we've actually been doing things a little bit differently. We've had a lot of fun working with folk from sports science, medicine, physiology, and training, trying to see how people are going to be using facilities like this to basically make them work better, live better. So we have a big program on healthy aging, for example. So this young lady is not particularly aged, but she is wearing a certain type of footwear which aging folk would like to wear. So she's trying them out on VSim. Okay, so you can see there 9 force plates. This is probably the biggest array of force plates on the planet, and we've got the motion capture arrayed around here. So she's wearing a motion capture suit with markers on which are going to be tracked, and we should be able to see a kind of a virtual representation of that and diagnose what the movements are and how she's behaving. And we should be able to spot people who sort of issues, for example, with problems with the knee or the hip, and help to diagnose that. On the right hand side, we've got one of our colleagues who's doing work on Parkinson's disease. So this is Will Young, no relation, a different Will. Okay, and what we've got, he's wearing VR, and we deliberately, did you see that? We actually sort of put a little bit of a motion in there. So we deliberately shook the platform to the side to sort of upset his balance. And by seeing how he recovers from his balance, he's obviously young and fit, but other folk will not be quite so young and fit, and we can see how they behave, and then we can try to design facilities like transport and living facilities to work better for people as they age. So it's going to be a fairly useful facility, not just for engineers, but also, as we increasingly find in other disciplines, very, very wide disciplines. We're only scratching the surface so far. And it's actually tremendous fun working not just with Holovis, but all these other folk in different disciplines. So it's a great research tool for us to have. It's brilliant, in fact. Okay, so I think I'll leave that one there and go back to you guys. Where are we now? Okay, Chris and Drew and Stuart.
Drew and Stuart, you're now
thanks.
live.
Great. Thanks, James. So,
Any questions?
Any questions coming in? Rob, have we got any interesting questions?
We're just going to have a quick look. No questions at the moment, but I want to ask some. And yeah, I just think that, like, if you've got any thoughts about, if a student's watching this and they're now thinking to themselves, what is the potential for VR, and what is the potential for what other tools can be used in this way?
I think from certainly the industry we work in as a broad range beyond what we've demonstrated this morning with the VSimulator, VR or immersive experiences connected with very clever, very smart technologies like the motion platform, like the force plate technology, and obviously all the underlying capabilities that were needed to be brought together for that system, have a huge future, as we know, as the technology, especially around the levels of immersion and the way that we can create incredibly realistic synthetic environments that either replicate the real world or take us into, you know, any future environment. That's going to be really important for education, for industry, that continued progress, that continued improvement around the synthetic worlds carries on, and we're seeing it at pace here. And it's beyond obviously virtual reality as we know it in headset. It's the mixed reality generation that we're going to be seeing with more of the augmented type immersive glasses, and that future technology that will effectively change the way we design experiences going forward as well. So I think for those watching and those that, you know, are really keen to get into this type of industry, it's huge. The opportunity is vast. There's so much that needs this technology to help solve problems like the one we've done with Exeter at university. that the world really is their oyster. If they've got those skills and those behaviours around the kind of things you've seen today, there are many more companies like Holovis all over the world that are interested in it and that are screaming out for brilliant people with all those different multidiscipline skill sets to solve problems.
Do you think that with COVID-19 that there's going to be even more need for VR and augmented reality and these situations where you have to be able to test things and do things remotely and not keeping distance, or run the potential for it?
Yeah, absolutely. I think what we've all learned about the new norm that we're all in now is that trying to be connected through the challenges we've had and continuing to do that safely as we do open up. We know it's worked where we can get big workforces working effectively from different geographic locations from home, and having access to technology. And there's still barriers there, obviously, around things like virtual reality and the cost of headsets and computers to run it. But as the technology becomes more mature and as we get to a point where it is far more adoptable and it is in the home, then certainly that's going to affect the way that people can remotely collaborate and join each other in the virtual environments as though they're there. At the same time, we've also got to be very conscious that back in the workspace, the corporate space, the industrial space, the old norm of sharing headsets is obviously something that lots of people are going to be far more conscious of the risks around now. So that has made us rethink some of our more large-scale immersive environments, like our VR caves and our bigger immersive rooms that we build, where people can socially distance and operate in them as well. So we're seeing a resurgence in both areas, actually. And again, it's all for how we open up again and work safely that we're all focused on. So yeah, I think there's a big push now, as we all know, into greater adoption of the technologies and better use of it as we go forward.
Is there anything particularly cool that you are finding really interesting and that as a company or you'd like to get into, or you think that students should look out for, that they can access and get involved with?
I know for me, I don't know, Drew's probably got something. I know the mixed reality is really so exciting, where you look at the next generation. We're playing with HoloLens 2s here at the moment, where we're augmenting information in real time over vehicles, over cars. When I see that technology and what our engineers are pulling together with the future in mixed reality, it's just incredible where that can go. I don't know, what do you think?
There's some very interesting interactive devices that are coming out. I saw one just the other day. It's a ring, literally a ring that you can put on your finger, and allows you to interact in an augmented reality just with hand gestures by wearing this ring. So there's definitely some interesting technologies coming out at the moment that's supporting us. Yeah.
Do you think there's things that we could exploit like that at the university then? That, like, for example, a student's walking along, they're wearing a ring and they flash it at a screen and it then tells them their timetable or something like that. I don't know, how could we use that?
Yeah, for sure. There's we actually have another technology that we're developing here called HoloTrack, which may actually give those kind of solutions. It's all around being able to seamlessly and frictionlessly interact with the technology that's around you, and have it aware that you're there. So if there was a screen on campus that could be used by someone, just being able to walk up to it and waving your hands, it realizing it's not just a person, but it's you in front of that screen, and then bringing up your timetable. That's definitely stuff that we're working on at the moment.
Great, thank you so much, everyone, for your time. I'm just going to switch back to the Digital Hub now. So we're on Streatham campus, and you can see that we're here. The sun's actually come out a little bit as well, which is really great. As I mentioned, we've got coffee, we've got donuts, we've got amazing speakers. We've got 17 speakers alone this week that we're going to be putting live streaming. Some of them are going to physically be here at the Digital Hub as well. I think it's a really great opportunity for students to fall back in love with digital, because we know that you have had to just study, work and remotely, and you've kind of been forced into that because of COVID. But I think there's now an opportunity to listen to some of these speakers that are going to be here and find your new love of digital. I hope that's okay. Okay, we've got a question just quickly coming in. I think James might have to drop off because I know he's got another session, but that's okay. Hopefully Stuart and Drew can stay on. Someone said, in relation to research, has any work been done with NHS partners to model possible contributions these tools could have on services, e.g. fall management, reduced hospital emissions, things like that? That's a cool question. I like that.
Well, okay, maybe I can answer that one. Yes, that's happening. We're working with physios from St Luke's, in particularly in this area of trips and falls, and we're looking to use VSim for studying ways to diagnose, this performance and find better ways to manage it. So yes, it's very much going to be a tool for healthcare going forwards. Yeah.
Okay, there's one more question in the chat as well that's now come through, someone's asked question from the audience: how can students get into VR with lower budgets?
That's yeah, great question. I would probably point you at two main things. First is Unity. Unity is an engine, as a virtual reality engine. It would be free for you guys to use as doing your projects, and it has a wide support for virtual reality tools just built in, and it has an amazing set of tutorials and lectures that go along with that too. When it comes to actually then putting that on a device, it will support things like just VR on your phone. So you would literally be able to upload your projects to your phone. Google Cardboard-esque type virtual reality, and that would definitely be a great entry point into the technology there.
That's great. Thank you, Drew. That's really, really interesting. Okay, so I'm just going to have one last check of the questions. No, we've got no more at the moment. We'll upload this as a recording, though, to the Digital Hub, which is our SharePoint space for all students to engage with the digital tools that we use at the university. There's a comments section on that page, so if anyone gets any more questions, we can direct them back to Stuart and Drew. And Holovis, I'd just like to say thank you so much for your time today. I found it really interesting, and I'm sure the students will do too. Thank you.
No problem at all. Absolute pleasure. Thank you.
Okay, we'll see you soon. Thank you. Bye bye.
Cheers, everybody. Take care.